I'm handling what we call a rake, but it's really a sieve. It was, after the first few missions, we realized in the analysis of the samples that were brought back that this size rock gave us a much broader sampling of the, away from the landing site of material that had been thrown in there by medium impacts. And so we were collecting, at each major station, we just take a bunch of one of these scoops and sieve the fines out and of course save the other rocks. But we sampled a lot of the fines as well. I mentioned the water-cooled underwear. That was an enabling technology. Believe me, you could not have worked in that suit for 8 hours as we did without that kind of cooling. That's the Challenger right out there, and that's that light-colored spot I mentioned around it, about 3.5 miles away. And this boulder had rolled down the side of the northern wall of the mountain, of the valley, the North Massif, we call it, from about 1.5 kilometers away up the side of the mountain, so we knew exactly where it came from. And it was the only boulder we could see on our pre-mission photographs. So the pre-mission photographs weren't that great. They were good enough for planning, but not for identifying the boulders. I have now begun working with some of the lunar reconnaissance orbiter photographs that are coming back of the landing sites and other parts of the moon. And they're at about 1 meter resolution, and you not only can see this boulder, but you really do see the boulder, and there's boulders everywhere, and in particular, you can tell which boulders have tracks behind them. And this is the boulder track right here. You can see my footprints out of sight, up the other side. And that track can be traced 1.5 kilometers up the side of the mountain, so you know where the boulder came from. So if we'd had that kind of information where we went, we probably would have done a much more systematic sampling of these large boulders, because we could tie them to where their outcrops were up on the mountain. Those footprints, by the way, will stay in recognizable form for about 1 million years. You want to leave your footprints in the sands of time, that's not a bad place to do it. Well, we left the moon after 75 hours, had 3 excursions, as was mentioned, and but we eventually had to go. This is not a good picture because it was taken off a television monitor on Earth. The camera was on the lunar rover, parked about 300 meters away, and this was the first time that the controller at Findell, who was controlling the camera, was able to time his command so that he actually got a picture, and he followed the spacecraft all the way up. He had to lead that with all the electronic delays and everything, plus the communication delay to the moon, by 6 seconds to get this picture. It took him 2 other missions to figure out how much he had. That's what's left of the Challenger. If you may remember that this was the hatch, and the platform used to be there. That was all connected to the descent stage. Ron Evans took this picture of himself while we were away, and I show it because he is demonstrating that even though we produced our water in fuel cells, hydrogen, oxygen fuel cells, a little bit of hydrogen always seemed to go across the catalytic bed and into the water. And this is a bubble of hydrogen in a bag of salmon salad. Salmon salad was our experimental food of choice. We did a lot of things other than eat it. It did fine, but salmon doesn't travel well under very many circumstances, unless it's still alive. But we always wanted to let the engineers know they hadn't figured everything out. One of them was how to keep the hydrogen out of the water. It took us 3 days to come back. We came back faster than we left because we wanted to make up that 2 hours and 40 minutes in order to be where the Navy thought we would be when we came back. We actually splashed down in the Pacific within 1 minute of the planned time, again, before we left the Earth. Before we, even before that, 2 hours and 40 minutes. And it meant that I got 2 hours and 40 minutes less space time, but nevertheless, the Navy was happy because they didn't have to redeploy their ships. And the only real ship we had was the Ticonderoga. Some of you may be former naval persons and remember the Tycho. Ron Evans actually flew 2 tours of duty off the Tycho, so it was like coming home for him. One problem that Ron always had was waking up. He was a very heavy sleeper. He actually slept through a wake-up call while we were in flight. And apparently they finally determined when he was a pilot that they had to put an old-fashioned alarm clock in a steel basin to get enough noise to wake him up. And we didn't have that much noise on board, and so he was about an hour late. And the only way we knew he was still sleeping is that I was sleeping under a couch, and I rotated and could look up between the couch at our caution and warning panel, and the red warning light was on. Well, that's because the ground had activated the whole warning system trying to wake him up. And I reached up, just automatically what you do after training is to turn that off so that if another failure occurs, it will come on again. Well, I reached out and touched it, and it was almost hot enough to burn my finger. It had been on so long. Because they could turn it on, but they couldn't turn it off. We gave Ron a hard time. Well, one question is always, is what's next for space, and we really don't know right now. The president has proposed to cancel the return to the moon effort that was underway for the last 6 years, and in favor of not doing much except technology development without any real objective in space. A lot of words and promises, but it's really a pullback for the nation, and I think a very dangerous situation for America in not being competitive, much less dominant in space as we have been in the past. But that's a different set of discussions, and some of you may have more important questions to ask. This, by the way, is the Earthrise picture that I took on Apollo 17. As you can see, the Earth was approaching its new phase, and but still quite a remarkable memory of just what it means to have gone to the moon. We committed a generation, in a sense, to a environment totally different than the one in which humankind had evolved. Philosophically, I think that's very, very important. Psychologically, I think it's very important because it really broke that barrier. It bent the curve of our technical evolution, at least, to where we now know we could live on the moon if we decided to do that independently, ultimately, of the Earth. And I'm sure the same thing applies to Mars based on what we know right now. So it is indeed an exciting time in human history. What role the United States will be playing in that history is still uncertain.